Let's go ahead and continue with chapter 3.1. We left on closure and now we're going to move to subtraction, but I want to make a note in the textbook here. Again, what I called the magic of numbers, right? This journey of discovery. And so it comes from a source where we talk about why we would want to talk about closure. So I urge you to kind of take a minute to read that and before we move on to subtraction. But again, the idea that closure isn't just a math rule, it's a powerful force that drives new ideas and deeper understanding. So make sure you take a minute to look at that. Subtraction, play the video, take a look. It's an amazing kind of video with Rebecca doing 7 minus 3. So it's for sure worth the time again to go through some of these ideas in the video. And we start off with the definition of subtraction. And of course, one way we look at that is through what we call the takeaway approach. So let's go to the notes there, right? Really thinking about subtraction. So takeaway is for sure one of the methods that we learn. Takeaway 7, takeaway 3, and you can, in the words, you can see what's going on here, right? And so that's one way to approach it. The takeaway approach from a set model, you have these elements and you take away. You have takeaway approach on a measurement model, which we've talked about now. Change the color. Talked about set models and measurement models. And then this comes back to the difference. Remember in our set theory work in chapter 2.1, we looked at the difference between two sets, right? You take away all the elements from one set and that's it. So it's the same idea. The difference between the number of elements would be the number of elements and the difference of those two sets. The first example asks you to use the set theory definition to do 5 minus 2. Well, you create a set here, two sets with elements, and then you subtract them. The difference between A and B is A, B, C. Notice how many elements is 3. Number of elements in A is 5. Number of elements in B is 2. So it's 3, which we knew that already. But again, this just really formalizes the mathematics around the use of sets, right? But then we start to just learn the idea of just the values in those sets. Another approach to subtraction is what we call the missing add-in approach. And that's the idea of that A right here. Oh, this was it here, right? You have A minus B is a whole number C such that, right, we know it is, or let A and B be any whole numbers. A minus B is the whole number C such that A equals B plus C, meaning we have this relationship between subtraction and addition, right? So again, that's the official language there, but the answer C is called the missing add-in. Like, how do I solve 7 minus 3? Well, I do 3 plus what equals 7. And so that's what gets me that missing add-in, the missing number to add together to get me up to the 7. Some would call this the counting up idea, right? The counting up to solve a problem. And so wonder, play, grow, again, these are these chances in class that we have to work together in small groups. But with an online model, if you're doing this at home, you have to kind of challenge yourself to think about this, or maybe bring someone along with you to think about this. And so you have these different situations, and we've identified the model, set model, measurement model, takeaway, missing that. And again, think about it. Some of the questions, how you word them, are more obvious towards that type of model, but the models are about how the children are thinking about solving the problem. Right? We're not forcing it on them. We just want them to, we have to identify how they're thinking. Are they using objects? Are they imagining number lines? Or is the problem like a physical movement, which more overlays to measurement models like C, running miles? So that seems like a measurement. But a student may see it as a set model, or how they solve problems. Are they taking away or are they adding on? And we don't know. We don't always know. And that's why you want to, how do you figure out how to make their thinking visible as we do that? So again, as you're going through, I've identified the ways. This is also a good place potentially if you need extra help to, again, of course, if you don't have somebody, I think for sure um, an AI system where you could ask questions, have a conversation around that would be a good way also to kind of reinforce your understanding around set models, measurement models, take away missing add-in. Because I wish I could prompt you to ask me a question now at this point, but something to think about with those approaches. Which leads to some of you who work in schools may be familiar with, or with your own children, or your um, um, work with family members, that we have this we call this relationship. Some people call it the fact families, the four fact families. You do it for you have this for adding and subtracting here, and so that's what the next example is just trying to create a statement from each of those. Now, again, if you need some more, the textbook has a little bit more, but this is why it reminded me. I did put it into an AI system, the question, to kind of give me an example of a takeaway approach problem. And so if you want to zoom in and take a look, and I asked it to give me a missing add-in a problem, which some people call additive comparison. I like missing add-in, it makes sense, of problems that lend itself to those methods. Doesn't mean a student will do it in that way. But just look at the wording of the questions. I thought that was, I wanted to see what a chat bot would give me. And then it did a nice little summary for me. Takeaway treats subtractions removing, missing add-in treats subtractions finding the difference for two numbers, or completing a part-whole relationship, right? I'm looking for that add-on. So something to think about there as we do that. Okay, let's continue on. Oh no, we're done. Sorry, I have one last example here. I'm going to finish this up right here. Um, um, Again, thinking about the relationship, and so notice subtraction is not closed. Oh, sorry, for whole numbers, because 5 minus 3 equals 2, 3 minus 5 equals negative 2. So just because you subtract two whole numbers, the answer is not always a whole number. Which leads us to the last example. 0 is closed because 0 minus 0 equals 0. And then in this case, 2 not closed, because if you change the order from small minus big, you always get a negative number, which is not a whole number. So that's it.